Welcome to today's video, 150, Evaluate Reverse Polish Notation. So, you're given an array of strings that represents an arithmetic expression in a reverse Polish notation. Now, let's go ahead and take a look at what that means. Operators follow their operands. So, for this explanation here, when we add 3 and 4 together, the expression is 3, 4, and the plus sign instead of 3 plus 4. Okay, that makes sense. We want to evaluate the expression and then return an integer that represents the value of it. Okay, so valid operations, plus, minus, multiply, and divide, each operand can be an integer or another expression. The division between the two integers has to always truncate or round down to 0, and there cannot be any division by 0. Okay, that makes sense. And it's they're integers. Okay, so we're given this example here. 2, 1, plus 3, and multiply. And we're going to want to return 9 because we add these two numbers together, 2 plus 1, and then we multiply the result of that with 3. Makes sense. Same thing with this example. We have 4, 13, 5, divide plus. Our output is going to be 6 because we add these, we add 4 with 13 and 5 divided with each other, and then we add it up at the very ends. Okay. Okay, yeah. This kind of reminds me, a little bit of a side tangent here, but this kind of reminds me of Lisp in a way, which is programming language that I took back in my first year of university. So, yeah. So, okay, an idea of how to do this would be by utilizing a stack. So what we could do is we could have a stack, and then we put a stack of all of the elements in here, and then what we could do is we could pop the last element from the stack from there and check to see whether or not it's a number, like an asterisk or any those operations. If it's a number, we just append it. We just append the element to the stack, and then if it's not a number, if it's an operation, then we pop those two elements in the stack and then perform the calculation before adding that as a value itself. So yeah, so I guess we can write this down first. So with every element in a list, what we're going to want to do is we're going to want to add to a stack if number. If not, we're going to want to perform operation and then add operation to stack afterwards. So let's say we're given 2. Okay, so we can run this through with an example in a stack over here. So with this list, we add 2, we add 1, we go to the plus operation, and because it's not a number, we, instead of adding this plus to the stack, we pop the two previous elements from the stack, perform that plus operation, and then add the result of that at the very end to the stack. So that'll be 3, whereupon 3 will be then added again over here, and then we see the asterisk or the multiplication symbol, and then we perform the operation again, popping the last two elements in the stack, 3 and 3, and outputting 9 at the very end. So yeah, we can go ahead and begin implementing this now. We'll have a stack at the very beginning. We can do list implementation in Python, and then for value in tokens, for every single value in that tokens array, what we're going to want to do is we want to check if a value is equal to plus, then you use something, and then same thing with minus. Oh, let me copy this. Or yeah, okay. If v equals minus, we do something. If v equals asterisk, we do something. And then if v equals divide, then we do something. So we perform operations for those. Else, if it's not any of these, we can assume it's a number, and then actually we'll make this elifs instead. Otherwise, if it's none of these things, then we're going to assume it's a number, and we're just going to append that simply to stack. So we do stack dot append the integer value of that current element. So we'll do that. For adding operations, all we really have to do is, like we said, check those perform operation by popping two elements from stack, appending res to stack. So we'll just do that for the plus and the minus one. So we'll go ahead and do stack dot pop plus stack dot pop. We pop those two elements in the stack, and then we'll append the result of that back into the stack. So we'll go ahead and do this. Same thing for the minus one. Just do the same thing, except with the minus symbol. Or actually, wait, no. Same thing with the multiply one. We're gonna go ahead and perform the same operation. For the subtraction, what we actually need to keep in mind is the order of it matters, and the specific order we want to do, because it's reverse Polish notation. This needs to be 2 minus 1. If we pop those two elements like that and do a subtraction symbol, then it'll be 1 minus 2, because the pop always refers to the very top element in the stack. So in order to account for this, we have to, I guess, declare different variables and then do it in reverse. So what we can do is do maybe like a b equals stack dot pop. So now we have two references to it, and now what we can do is do b minus a in order to append those two values subtracted together in reverse. And with division, the order also matters as well. You need to complete the equivalent, except this time we do a division symbol. Okay, so we'll go ahead and take a look at the criteria again. Valid operations, we have all of them. Okay. Integer or another expression, yep. Okay, so this one, it has to always truncate towards 0. Now, if I remember correctly, the default implementation of the division thing in the division operand or operator in Java and C++ already accounts for this. It truncates towards 0. For Python, what we actually have to do is we have to surround this with an integer converter in order to account for this, because the default implementation of the integer function truncates towards 0. And we'll also return an error here if we don't convert this to a float first. Yeah, so this will return the value of that expression afterward, and it should be done in integer format. At the very end, what we can do then is basically return the topmost element in the stack, because at that point it'll be finished. So return stack minus 1. We're returning the very top element in the stack because that's what'll be left after everything is completed. At the very end, the only element in the stack left will be 9. So we'll go ahead and run this as a test. Oh, right. I need to check to see. Okay. Take a look, syntax errors anywhere. For valuing tokens, we check to see this. Yeah, should be good. Okay, yeah, accepted cases. We go ahead and run this. And there you go. So, yeah, that's how we're going to do it. Yeah.